This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So in the last previous sessions, we have discussed about principal stresses and principal planes and principal strains we have discussed. So here the principal stresses are, we have derived some equations and calculated how to calculate the maximum and minimum principal stresses and how to find normal stresses and shear stresses we have discussed in the previous sessions. So in this session, so I want to explain about construction details of Mohr circle. So how to construct the Mohr circle? What is this Mohr circle? So this is a graphical representation for a principal stresses. So by using this diagram, you can find the maximum principal stress and minimum principal stress. So up to now we have learned analytical procedure. Now the graphical method we will see in this session. So that the title of the today's topic is the construction of Mohr circle. So first of all, you should know about this topic outcome. At the end of the course, the student should be able to demonstrate the principal stresses, principal planes, and torsional stresses acting on any arbitrary plane within a structure using analytical and Mohr circle methods. So already we have discussed about principal stresses and principal planes in previous sessions, and also we have calculated derived equations by using analytical method. Now in this session, we will learn the Mohr circle method. So after completion of this topic, the student be able to demonstrate all these topics, the principal stresses and the principal planes, how to derive the equations and how to represent, how to find the maximum and minimum stresses by using Mohr circle method. So that is the main aim of this outcome. So now the Mohr circle, about Mohr circle, first we will discuss. So what is this Mohr circle? So the Mohr circle is a graphical method. Already I told you in first slide. There are two methods. One is analytical and another one is graphical method. The Mohr circle comes under this graphical method. Used in engineering mechanics, particularly in the study of stress and strain in materials. The stress and strain studying, so these are Mohr circle is used for engineering mechanics. It provides a visible way to determine the principal stresses, maximum shear stress, and the corresponding orientation of these stresses in a material subject to two-dimensional stress at a point. So we have discussed about these two-dimensional stresses. So whenever the element subjected to uniaxial stresses, so that is called as two-dimensional stress in x or y direction. So by seeing this Mohr circle, you can find the maximum principal stresses, maximum and minimum stresses, and also the maximum shear stresses, and also the corresponding orientation of the stresses. So whenever this material is subjected to two-dimensional stress. So what are the applications of this Mohr circle? One is stress analysis. So Mohr circle helps visualize and calculate normal and shear stresses on any inclined plane through a given point within a material. So the principal stresses, so for first application is stress analysis. In stress analysis, calculate the normal and shear stresses on any inclined plane. And second application is principal stresses, to find the principal stress. What is this? It defines the maximum and minimum normal stresses. You know, the maximum and minimum normal stresses are called as principal stresses. The normal and maximum, already we have derived equations for the sigma 1 and sigma 2. So the sigma 1 is the maximum principal stress and minimum principal stress. Maximum and minimum. That occur on specific planes where shear stress is 0. On a specific plane where the shear stress is 0, those stresses are called principal stresses. So the maximum shear stress, it also allows the identification of the planes where the shear stress reaches its maximum value. So it allows the identification of the planes where the shear stress reaches its maximum value. Whenever it reaches the maximum value, shear stress, you can identify the identification of planes. So that is the orientation of the planes. So these are the applications of Mohr circle method. The stress analysis and principal stresses and the maximum shear stress. So this is the Mohr circle. So Otto Mohr, scientist, developed this Mohr circle. So the graphical tool for the definition of the transformation equations for plane stress. Here consider the circle equation. X minus a whole square plus y minus b whole square is equal to r square. So this equation you can write in the terms of normal stresses and maximum and minimum principal stresses. Sigma n minus sigma x plus sigma y by 2 whole square plus shear normal stress, maximum the tangential shear stress is equal to sigma x minus sigma y by 2 whole square plus tau square x. So the radius here in the form of a circle, so that r square is equal to sigma x minus sigma y by 2 whole square plus tau square x. So that you can write the r is equal to the radius r is equal to square root of sigma x minus sigma y by 2 whole square plus tau square x. Here the center point for the circle sigma x plus sigma x minus sigma y by 2 whole square plus tau square xy. Sorry, sigma x plus sigma y by 2 comma 0. So this is average of these two stresses. It gives center point. So the where average normal stress is equal to sigma x plus sigma y by 2. So now, how to draw this, how to construct this Mohr circle, we will see the procedure. So the procedure, the first step is locate center point. So to construct Mohr circle, take an abscissa and tangential stress sigma t as the ordinate. So take sigma n positive to the right and sigma t positive downwards. So then angle 2 theta is positive when take counterclockwise. So these are the points important while constructing the Mohr circle. Clear? So one by one now we will see the stepwise. First locate center C for the circle at the point having coordinates are average. So already you have seen here average, that is average of maximum and minimum normal stress, that is sigma x plus sigma y or sigma 1 plus sigma 2 by 2. This is average and sigma n is 0. So measure OA and OB equal to sigma 1 and sigma 2 respectively to some scale to the same side of O. So here in diagram, I will show you the diagram. See the circular diagram for stresses Mohr circle, the stress element and the stress circle. At C, so the O point and the C coordinates are sigma 1 plus sigma 2 by 2, comma, and ordinate are 0. Here sigma t in x-axis and y-axis sigma n. Clear? So with C as center and CA or CB as radius, and the radius is half into sigma 1 minus sigma 2 and draw a circle. With C as a center and draw a circle CA and CB with O center, CA and CB. So here the CA center and CA or CB as radius and draw a circle OA or OB sigma 1 and sigma 2. So here O from O to A sigma 1 and here O to B sigma 2. So now draw a circle. At center C, draw a line CD at angle 2 theta in counterclockwise. So draw a line CD, clearly shown here with 2 theta. Angle 2 theta. From D, draw a perpendicular DE on the axis OX and axis DE from D to E on this axis DE on the OX. Then DE is represents sigma T and OE is represents sigma N. Clear? So I will draw very clearly here the diagram from O. This y-axis and x-axis. This is sigma n and sigma t. So here as a center C, draw a circle O, B and OC. The radius sigma 1 minus sigma 2 by 2. So now here this is sigma 2 and this is sigma 1. And then draw one line, and this is inclination, that is plane, that is CD, and draw one perpendicular line on E. So the radius is here R sigma 1 minus sigma 2 by 2. CA and CB. So from D point, draw a perpendicular DE on the X axis OX. Then DE represents sigma T and then OE represents the sigma N. So this is sigma T. And OE from A to here, it represents sigma N. From the stress diagram, this is called as stress diagram. CD is equal to CA, CD is equal to CA, CA, that is of sigma 1 minus sigma 2 by 2. Now you can calculate DE is equal to CD sin 2 theta. Clear? So what is CD? The CD is of average 1 sigma 1 minus sigma 2 by 2. So now substitute in this equation, you will get sigma T. So similarly, OE is equal to OC plus CE. The OE in this diagram, the OE is equal to OC plus CF. Sorry, CE. So the sigma N is equal to OC plus CE. OC, what is the OC? Sigma N. The DE represents OE represents on sigma N. That OE is equal to sigma N. So now the OE is equal to sigma N, that is equal to OC is equal to sigma 1 plus sigma 2 by 2. And the CE is sigma 1 minus sigma 2 by 2 cos 2 theta. So here sin theta you have taken for this sigma T. Similarly take for sigma N cos theta, cos 2 theta. See? So in this diagram shown this sigma 2 and this one is of sigma 1 plus sigma 2 by 2 and sigma 1 minus sigma 2 by 2 say as sigma 1. And then this is represents the ordinate is sigma T, axis is sigma N. So now in stress circle you have calculated the OE is equal to the OE distance. OE is equal to OC plus CE. So that is sigma T maximum when 2 theta is equal to 90 or radius of Mohr circle. Sigma T is maximum. Sigma T is 1 by 2 into sigma 1 minus sigma 2 into sin 2 theta. 1 by 2 sigma 1 minus sigma 2 into sin 2 theta. This is sigma T. So here 2 theta is equal to 90, then sin 2 90 is 1, therefore sigma 1 minus sigma 2, that is sigma T, or radius of Mohr circle also sigma 1 minus sigma 2. So here see the Mohr circle for the general case of plane stress and simple shear drawn. So in this two-dimensional dimensional stresses are acting on this element sigma 1 and sigma 2, and here see in stress circle shown sigma 1 here OA and sigma 2 is OB and sigma N is OE and sigma T is equal to DE. So here also drawn one AB line and then from A to draw one perpendicular line and B2 perpendicular and bisecting line is center. From this C point draw a circle. What is the circle radius? the circle radius is here of sigma 1 minus sigma 2. So sigma 1 minus sigma 2 shown in this diagram. And here the sign notations are important. The downward this one shear stress is positive and upward is Q, minus Q is negative. Already I told you in the starting point, positive to the sigma t as the ordinate, take sigma n positive to the right and positive downwards. So here positive downwards, and in this diagram shown sigma n and sigma t. So this dotted line represents the resultant stress. Resultant stress. So the resultant stress, the maximum stress and the minimum stress. Here in this diagram shown that the empirical relations. So this is a detailed diagram shown. See, sigma 1 plus sigma 2 by 2, that is OC, and OA sigma 1 minus sigma 2 by 2. When it is theta is equal to 0 and theta is equal to 90 and theta is equal to theta at this point. Clear? So the maximum stress, the tangential stress occurs at sigma t, the maximum sigma t at 90. So that is at 2 theta is equal to 90 degrees. Clear? So the Mohr circle, when a body is subjected to two mutually perpendicular principal tensile stress accompanied by a simple shear. Here shown, the consider a rectangular body subjected to two mutually perpendicular principal tensile stresses of oblique and unequal intensities accompanied by a simple shear stress. So it is required to find the resultant stress on an oblique plane as shown in figure. So here consider a rectangular body when subjected to two mutually perpendicular principal tensile stresses of oblique unequal intensines accompanied by simple shear. So now we will discuss. So here let assume sigma 1 is the major tensile stress. Sigma 2 is minor tensile stress. And the shear is the top is shear stress across face BC and AD. So across face BC and AD means the diagram shown here, the BC and AD and AB and DC. These are the faces of a rectangular body. See here, shear stress across face BC and AD is tau when it is subjected to sigma 1 major tensile stress, sigma 2 is the minor tensile stress. The theta is the angle made by the oblique plane with the plane of major tensile stress. The theta is the oblique plane made with the major tensile stress, the plane of major tensile stress. So according to the principle of shear stress, the faces AB and CD will also be subjected to a shear stress of X. So according to the principle of shear stress, the face AB and CD will also subjected to the shear stress. AB and CD. The CD, the shear stress, and this AB phase also. So the sigma 1 and sigma 2, uh, stresses, normal stresses, principal stresses are acting. So now for this rectangular body, how to construct the Bohr circle? So take AB is sigma 1 and AC is sigma 2. AB sigma 1 and AC is sigma 2 towards right of A to some suitable scale. So draw perpendiculars at B and C and cut off BF and CG equal to the shear stress X to the same scale. So bisect BC at O. Now with the center O, center 1 radius equal to OG or OF. Draw a circle. So here the AB and AC right of A. So draw a on line A, AB and AC. So AC is represent sigma 2 and this is sigma 1. So now draw a circle. So draw perpendiculars at B and C and cut off BF and CG. At B and C. Here B and C perpendicular. So bisecting at this center of O. So draw a circle with cut off at BF and CG. BF and CG. So now bisect BC at O. Now with O as center and radius equal to OG or OF. Draw a circle. OG or OF. So this is draw one circle through this. Clear? So this is called as Mohr circle. Now remaining elements, remaining things construct according to the our previous procedure. So now you got the measure sigma 1 and sigma 2 and then CG. Now the angle, the theta, draw one inclined plane with respect to this x-axis. So that angle is here on O to E, that is 2 theta. E, that is 2 theta. And then E2, draw one perpendicular line, that is D, and then join this G to A like this. This is resultant stress and this is sigma T and this one is normal stress. So clearly here shown the final output of this Mohr circle, sigma 1 and sigma 2 and the radius OG or OF and a drawn plane with 2 theta. So let AE is the resultant stress on the oblique plane. The oblique plane is here shown with 2 theta. This is a resultant stress A D. AE is the resultant stress. The AD is the normal stress, sigma n. ED is the shear stress on the oblique plane or tensile stress. Clear? So the proof shown here in this diagram. So the how it is constructed, we will discuss here the points. The CO is half of the CB. The CO is half of the CB. You know, so why? Because bisecting at a O point. The AO is AC plus CO. AO is AC plus CO. So that is sigma 2 plus half of sigma 1 minus sigma 2. So why? Because the CB is sigma 1 minus sigma 2. So AC is sigma 2 and AB is sigma 1. So therefore, the CB is sigma 1 minus sigma 2. So from this equation, you can write the AO is sigma 1 plus sigma 2 by 2 and AD is AO plus OD. So OD in terms of cos, you can write cos 2 theta minus alpha. So alpha shown here in triangle BOF. Okay. So here sigma 1 plus sigma 2 by 2 AO plus the OD written like this O into cos 2 theta minus alpha. So next one, simplify this one, the cos 2 theta into cos A minus B. So cos A cos B plus sin A sin B. According to this trigonometrical quotient formula, expand this one, cos 2 theta into cos alpha plus sin 2 theta into sin alpha, and then sigma 1 plus sigma 2 by 2 plus OE cos 2 theta into cos alpha plus OE sin 2 theta into sin alpha. Now take here the alpha terms and 2 theta terms, cos alpha into cos 2 theta plus OE into sin alpha into sin 2 theta. So this one you can write in terms of OF, OE is equal to OF. According to the diagram, OE is equal to OF. OE is equal to the OF. So that is radius. So instead of this OE, you can substitute OF. So now see, the OF cos alpha is equal to OB and then OF sin alpha is equal to BF. Now substitute in this equation. In this equation, you will get the final equation is sigma 1 plus sigma 2 by 2 plus OB cos 2 theta plus BF sin 2 theta. So here you can write in place of OB CO and BF is equal to tau. OB is equal to CO and BF is equal to tau. You can write tau. So now sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau sin 2 theta. So why? Because the CO is sigma 1 minus sigma 2 by 2. Now substitute and then simplify, you will get sigma n, that is normal stress. So now the ED write like this: OE into sine 2 theta minus alpha, and again write this equation according to the trigonometric formula: sine 2 sine A cos B minus cos A sine B, sine A minus B, sine A minus B. Use sine A minus B formula and then substitute. Simplify here, you will get OE sine 2 theta cos alpha minus OE cos 2 theta sin alpha. And then write this equation instead of OE, take OF radius, and then substitute the OB is equal to CO and BF is equal to tau. So finally, right, you will get the tangential stress. The tangential stress ED. The ED. So this is the tangential stress you will get. So first, according to the Mohr circle, you will get the sigma n AD. AD is sigma n and ED is equal to sigma t. So how to derive the proof for this AD is equal to sigma n and ED is equal to shear. So that's why we have done like this. The sigma t is the tangential stress. Clear? So now you got proof for this diagram, the ED, tau and the AB, sigma n. So the maximum and minimum values of normal stress. In a Mohr circle, the normal stress is given by AD. Already we have derived. Hence the maximum value of AD will be when D coincides with M, and the minimum value AD will be when D coincides with M. So the AD will be D coincides with M, and minimum value of AD will be when D coincides with L. Whenever the D coincides with M, that is maximum value, and whenever D coincides with L, this point. So this point is coincide, this D in this diagram, the diagram D coincides with L, we will get minimum. The D coincides with M, this M point, this is maximum. So max and minimum. Whenever occur like this, you will get maximum and minimum values of normal stress. So the maximum value of normal stress now, see the normal stress is equal to AM is equal to AO plus OM according to the figure. So you know that AO is sigma 1 plus sigma 2 by 2 plus OF. The OF is the radius. That OM is equal to OF, that is equal to radius. Now you will sigma 1 plus sigma 2 by 2 plus the OF is equal to OB square plus in triangle OBF, OF is equal to OB square plus BF square in triangle OBF. See in the diagram, go back to our diagram, OBF. So in this, OF square is equal to OB square plus BF square. So diagram, take this one in the triangle OBF. So the OF square is equal to OB square plus BF square. So the OB is equal to sigma 1 minus sigma 2 by 2. The BF is equal to 2 tau. So this is sigma 1 minus sigma 2 by 2. And the BF is tau value. So now substitute in this equation, you will get sigma 1 plus sigma 2 by 2 plus square root of sigma 1 minus sigma 2 by 2 whole square plus tau square. So the minimum value of normal stress, this is maximum value of normal stress. Whenever the D coincides with M. Now to calculate the D coincides with L. So the minimum value of normal stress. So that is AL is equal to AO minus L. So here take the LO is equal to OF, that is radius, and substitute. You will get sigma 1 minus sigma 2 by 2 minus sigma 1 minus sigma 2 by 2 whole square plus tau square. In the maximum, see, observe here, the positive sign occur, and in this case negative will come. So that is the difference between the maximum and the minimum. For maximum normal stress, the point D coincides with M, but when the point D coincides with M, the point E also coincides with M. The point E. So what is this? The E also coincides with M. See, when the angle is 2 theta is equal to alpha, the line OE coincides with the line OF. Thus, then the theta is equal to alpha by 2, and then tan 2 theta is equal to tan alpha. That is, you can write in terms of tau by sigma 1 minus sigma 2 by 2. Clear? Here, shown that tan 2 theta is equal to 2 tau by 2 tau by sigma 1 minus sigma 2. This is the orientation of the plane. So whenever the maximum normal stress, that the point D coincides with M, and also the E also coincides with M when the angle is 2 alpha. 2 theta is equal to alpha. So now the tan 2 theta is equal to 2 tau by sigma 1 minus sigma 2. So for maximum and minimum normal stresses, the shear stress is 0. Hence, the planes on which maximum and minimum normal stresses act are known as principal planes, and stresses are known as principal stresses. In previous session, in introduction part, we have defined like this. So whenever the normal stress, the shear stress is 0 on an inclined plane, those stresses are called, available stresses are called principal stresses. That plane is called as principal plane. So here occurred the stresses are maximum and minimum stress. So for minimum normal stress, the point D coincides with point L. When the D coincides with L, the point E also coincides with the L. So then the maximum value of shear stress, you can calculate, the shear stress is given by ED. According to the diagram, the shear stress is ED, hence the maximum value ED will be E coincides with G and D coincides with B. The E coincides with E, go back to diagram, E coincides with G, this one, and coincides with M. So the minimum normal stress, the point D coincides with the point L, and point D coincides with L, the point E also coincides with the L. See, the maximum shear stress is equal to, you can write OH is equal to OF from the diagram. So in triangle, again, take this OBF. You know, the OB square is equal to sigma 1 minus sigma 2 by 2, and VF is equal to 2. So what is this? How much this OF? So right, OF is equal to square root of OB square plus BA square according to the Pythagoras rule. So now the OB value sigma 1 minus sigma 2 by 2 substitute, that BF is tau value. So the shear stress, the tangential stress maximum occurred at on plane OH is equal to OF. Clear? So now finally we got the shear stress. Shear stress is equal to sigma 1 minus the maximum the tangential stress is equal to sigma 1 minus sigma 2 by 2 whole square plus tau square. So like this now in this session we have learned so how to construct the Mohr circle and the proof for the normal stress and shear stress, and also the orientation plane, the angle tan 2 theta and sigma 1 and sigma 2 calculation. So that is sigma n and sigma t and sigma t maximum also we have discussed. So this is the purpose of main the Mohr circle. So up to now we have defined the principal stresses and the principal planes, and then analytical method for its representation of this normal and this maximum and minimum principal stresses, and also graphical method. So that is the Mohr circle method. So by seeing this Mohr circle, you can say the maximum and the minimum values. So once again here see the Mohr circle. So in this circle, by seeing this circle, the all the values parameters of this diagram. So what is the radius and what is sigma n and what is sigma t? So you can say. So that is the advantage of the Mohr circle. When a body is subjected to two mutually perpendicular principal planes, you can calculate very easily the maximum and the minimum stresses, and then shear stress, the maximum shear stress. Clear? So now for this PPT, I have taken references like this. Rama Amrutam. The title of the book is Strength of Materials, and then the publishers are Dhanpati Rai and R.K. Rajput. The title of the book is Strength of Materials, and so and R.K. Bansal, textbook of Strength of Materials, title Lakshmi Publications, and R.S. Kurmi and Gupta, that is Strength of Materials. The title of the book is Strength of Material, and then others are R.S. Kurmi and Gupta, and the publishers are Chand and Core New Delhi and editions 2013. So you can take the latest edition, new editions also available. So these are the references I have taken for this PPT. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.